Okay, temperature change. We've added 8 grams of sodium nitrate to this glass beaker, 50 cm cubed of water, and we're measuring the temperature decrease. It turns out that dissolving sodium nitrate in water is an endothermic reaction, which means it takes in heat from its surroundings, which means there's a temperature decrease. So we have to calculate the average decrease and ignore the anomalous result. So here are the results. Well, this one is clearly the anomalous one because it's quite different to all the others, so we ignore that one. So grab your calculator, add up 5.9, 5.7, 5.6, 5.8 and divide by 4 and you get 5.75 degrees C. That's the average temperature decrease. Since these temperatures are only to one decimal place, you can also write 5.8 degrees C. The 5 pushes that 7 up to the 8. My advice in the exam would be to write both down. Hedge your bets. You don't know which one they're looking for. You'd probably get the marks for either, but I would write 5.75 degrees C, which equals 5.8 degrees C to 1 dP. Write exactly that in the exam. Right, suggest one change to this apparatus which would improve the accuracy of the results and give a reason for 2 marks. Right, the beaker's made of glass, so we can improve the thermal insulation properties of the container. One improvement would be to use a container made of polystyrene, maybe a polystyrene cup. And give a reason, polystyrene is a better thermal insulator and therefore it would reduce the heat transfer from the surroundings to the contents of the cup during the experiment. Okay, what else can you say? You could also say add a lid, and again the reason is the same, that reduces the thermal contact or heat transfer from the surroundings to the experiment. You could also say that you could insulate the beaker, add some form of insulation around the beaker itself, and again the reason is the same, that reduces the thermal heat transfer from the surroundings to the experiment. Okay, it prevents heat gain basically during the experiment. Right, next question. This time they're doing a similar experiment, but instead of, okay, that was sodium nitrate, NO3 nitrate, and like I said, that turns out to be an endothermic reaction. This is a temperature decrease. You do the experiment again with sodium carbonate. Okay, it turns out that that is exothermic. Exothermic means it releases heat energy to the environment, and therefore you're starting with a temperature of 20 degrees C. The temperature rises to these temperatures here. Okay, what do we have to do? We have to describe the relationship between the mass of sodium carbonate added, so they add these different masses here, and the final temperature of the solution, this column. So we have to describe the relationship between this column and this column for 3 marks. Okay, well, what do we notice? As the mass increases, the temperature increases up to a mass of 10 grams and temperature of 26.6 degrees C. So that's the first thing to say. So first say, as mass increases, the temperature increases. That's it. And then say, the temperature remains constant at 26.6 degrees C, even though the mass increases. Okay? Now, that will get you the 3 marks according to the mark scheme. You get the marks for this. You get the first mark for saying that as the mass of sodium carbonate increases, the temperature also increases. You get the second mark for saying from a mass of 10 grams onwards and temperature of 26.6 degrees C, it stays constant. And you get the third mark for using the word constant. You have to say that the temperature remains constant. There you go. That's how you extract 3 marks from that question. And I think that's everything. Yes? Good. There we go.